The Earth evolved from gas billions of years ago. A swirling ball of this gas then cooled and solidified to form the planet. As the gas solidified, the centrifugal force created by the spinning produced slightly more mass around the middle, and it became a distorted sphere. The Earth, therefore, is not perfectly spherical. It is slightly distorted, being more wide than it is high. This difference in diameter is called the Earth compression. The compression of the Earth is described in terms of its height, the polar diameter, against its width, the equatorial diameter. The polar diameter is some 27 statute miles less than the equatorial diameter. This equates to 23 nautical miles, or 43 kilometers. The difference between the equatorial and polar diameter can also be expressed as a percentage of the equatorial diameter, and this is 0.3%. Or as a fraction, it is 1/300th. The Earth's shape is referred to as an oblate spheroid. The Greek word for Earth-shaped is geoid, and this is sometimes used to describe the shape. There is a slightly larger amount of mass in the southern hemisphere, although this is insignificant in navigation terms. With ever-increasing technological advancements in avionics and navigational equipment, the significance of standardized models of the Earth is progressively more important. Many organizations in different countries throughout the world have produced independent models which differ in detail from each other. Modern navigation systems, for example those using satellite information, have position automatically corrected for the shape of the Earth. To have lots of different interpretations of the exact shape of the Earth could therefore be problematic and confusing in a global aviation network. A single model is needed, and the International Civil Aviation Organization has adopted the Earth Model World Geodetic System 1984, and this has become the standard model used for navigation around the globe. This Earth model is referred to as WGS 84. We have seen that the Earth is not a perfect sphere, with its equatorial diameter being greater than its polar diameter. For most of our calculations, however, we will now assume, for practical purposes and ease of explanations, that it is fundamentally a sphere. The Earth spins about an axis, called the polar axis. Additionally, the Earth orbits around the Sun, in an elliptical path, taking 1 year to complete a full orbit. An important factor of the way the Earth is spinning is that it is not spinning in an upright sense. In other words, the polar axis is not perpendicular to the plane in which it is orbiting the Sun. You can see in this diagram that the polar axis is not perpendicular to the orbital plane. The polar axis is inclined towards the orbital plane by an angle of 23.5 degrees. This angle of inclination is often referred to as the tilt of the Earth. We have seen that the Earth spins about its polar axis. The two extremities of this axis, where the axis meets the surface of the Earth, are significant points in the understanding of navigation. The two extremities of the polar axis are called poles. This lesson will give you an understanding of direction and the conventions we use in determining direction. Before we can define direction on the Earth, we need to select a datum from which direction can be measured. As we have seen, the Earth spins on its polar axis. We say that the direction in which the Earth is spinning is called east. All other directions are defined in relation to east. West is defined as the opposite direction to east. We can also use the poles to define direction. When we are facing east, the pole to our left is called the North Pole, and the direction to it is north. The pole on our right when facing east is called the South Pole, and the direction to it is south. We have now defined the 4 basic directions: north, south, east, and west. These are known as the cardinal points. The intermediate points that are midway between the cardinal points are known as the quadrantal points: northeast, southeast, southwest, and northwest. For navigation, cardinal and quadrantal directions are too basic and are not precise enough. For example, it would not be possible to navigate from one place to another based only on these 8 directions. What we need for navigation is a system that is more accurate and flexible. It must also be easy to use. The sexagesimal system states that clockwise rotation from north through east and south and back to north is a circle of 360 degrees. The cardinal point north is at 000 degrees, but the convention is to use 360 degrees. East is 090 degrees. South is 180 degrees. West is 270 degrees. And back to north, 360 degrees. The limitation of the 8 basic directions has been overcome. We can now use degrees to define a direction, from 0 to 360. When referring to direction using the sexagesimal system, we always use 3 figures for each direction, to avoid ambiguity. For example, 20 degrees is referred to as 020. This avoids possible confusion with 2 or 200. Similarly, 99 degrees should be 099 degrees. The term reciprocal is used to refer to an opposite direction. For example, the reciprocal of 120 is 300. To summarize, we have seen how to define the cardinal and quadrantal points, based on east being the direction in which the Earth is spinning. The cardinal and quadrantal points are insufficient for accurate navigation, and we therefore use the sexagesimal system to determine direction. Remember to use 3 figures when referring to direction. A reciprocal is the opposite of a given direction.